This is Severe Weather Awareness Week in New Mexico. This is Kerry Jones alongside Mark Fettig with today's topic, hail and thunderstorm winds. Let's first touch upon hail, specifically the science of hail. Hailstones grow by collision with supercooled water droplets. Two methods by which a hailstone grows: wet growth and dry growth. In wet growth, the hailstone nucleus, which is a very tiny piece of ice, is located in a region of a thunderstorm where the air temperature is below freezing but not super cold. Upon colliding with a supercooled droplet, the water does not immediately freeze around the nucleus. Instead, that liquid water spreads across the tumbling hailstone and slowly freezes. Since the process is slow, air bubbles can escape, resulting in a layer of clear ice. Now with dry growth, the air temperature is well below freezing, and the water droplet immediately freezes as it collides with that nucleus. The air bubbles are frozen in place, leaving cloudy ice. So with a thunderstorm, we're often focused on the strength of the updraft. The stronger that updraft, the larger the hailstone. In the case of an updraft with a strength of around 35 miles per hour, that potentially could allow a hailstone to grow up to a size of a dime, which is roughly 1/2 inch in diameter. Strengthen that updraft to near 100 miles per hour, and the potential for hailstones to grow to near softball sized increases dramatically. Softball sized hailstones are roughly 4.5 inches in diameter.
Well, Kerry, taking a look at the hail hazards out there, we have large hail hazards and, to somewhat lesser degree, small hail hazards. However, they're not. The small hail does create problems when it falls in sufficient quantity. Large hail can break windows and cause bodily harm. 1/2 inch hail size falls near 20 miles an hour, and you increase that to 3-inch size, that falls near 100 miles an hour, obviously increasing the chance of bodily injury. So it's best, obviously, to wait until the hailstorm is ended before you go outside to measure. Now, speaking of the small hail, as we did briefly there before, take a look at the picture behind. That indicates what can happen to the roads there in the lower right side of that picture. When you add enough small hail, it can create almost winter-like driving conditions.
Let's take a look at reported hail events by month, and you'll note that May and June stand out. In fact, May and June account for just over 50% of all hail events in the state. December and January are the only 2 months where we do not have any documented reports of severe hail, or I should say hail that is 3/4 inch diameter or larger. And in our database, we have about 9 events of softball-sized hail. Recall that's 4.5 inches in diameter. Most recently, there in Dora last June. So we can and we do see very large hail at times across the state. And again, May and June are the 2 months that we're most likely to see the large, severe thunderstorms and hail.
Kerry, let's take a look from hail, change from hail to winds as an issue with storms. Dry thunderstorms and downbursts related to that are fairly common in the warm season here in the southwest U.S. and also other states here, mostly here in the west half of the country. The downburst is strong downdraft with an outrush of strong or damaging winds on or near the ground. And again, dry thunderstorms are the biggest producer of those. Microbursts include a swath of damaging wind, which is less than 2.5 miles wide and lasts on average between 2 and 5 minutes. Because the radar sweep of 360 degrees is actually a little bit longer than that, those are very difficult to detect and warn for because they develop and decay quickly and we can't even see it. Kerry?
So if we just look at visual clues, some videos, downbursts in action in the upper left, that would be a daytime time-lapse video showing this descending, what we call a precipitation ball that strikes the ground, spreads out radially, and produces, again, very strong winds. This thunderstorm is moving from left to right. So obviously on the forward side, strong winds there as well. Take a look at this nighttime image, and you can see this massive rain-cooled air spreading out and generating very strong winds. As it does so, we'll play this one more time. And note this low cloud, what we call scud cloud, that develops right on the nose of that dust foot as it emanates out from the rain area. So very tremendous winds, and no doubt very strong and potentially damaging winds in both of these cases.
Well, taking a look, Carrie, at those damaging thunderstorm wind events by month, you can see that 55% of those are documented events in June and July. So obviously, as we get into the more of a thunderstorm producing season, that activity to develop across the area. And then January, the cool season months obviously are the lowest number of documented events. Terry?
Thanks for joining Mark and I for this Awareness Week topic. Thanks again and have a great day.